Modern physics correlates with relativity, with the idea that space is a low density vacuum, an almost perfect vacuum with no energy. And therefore, it cannot hold up planetary bodies or even universes. This is relativity in today's physics. This is illustrated by scientists Albert Einstein, vaguely, and other scientists. The Mitchell and Morley experiment that tried to get a perfect acceleration force for light. The cosmic effect. What is it that when two bodies are so close together, what is that space, because they are similar masses, uh, exist of that is compressed between them? If you read, when you see this or view this video, uh, as well as already know, uh, dark matter is space. It is a vacuum. But my thinking on this, big thinking, uh, is the idea that it works a negative space field, which means there's no detectable energy except for virtual particles that they observe. The virtual properties or particles exist in the Newtonian frame, and that is that as the planets exist and are in motion, orbiting at certain velocities and rotating, they exert uh, a charge between them. And this is Newtonian physics. Uh, what I mean to say is all these stars, like a solar system, they all work in harmony and they all work in uniformity, and they are consistent. And they are consistent to the Hubble sphere, the expansion field, which is space. So these positively, and this is not in your textbooks in universities. So the positive planetary bodies made up the same stuff that repel, as in the Casimir effect, uh, put a negative charge between them, which the cosmic experiment tried to find proof of. Um, Now, this charge is relative to a low density charge. And it must be doing something to make it have the ability for the planets not to fall. I mean, consider the planets as high density, very heavy, a lot of energy, and then space, that dark matter, is just the opposite. It's low density. There's no detection of any energy, but yet the planets don't fall. My idea comes from the Alcubierre warp drive. The negative energy produced in space, as Michael Alcubierre, uh, explains in his theory on warp space, or the space bubble, or exotic matter. Now, this may be exotic matter, but it's space. Instead of the attraction The space vacuum sucks up the energy in the planetary bodies, or that energy, and it makes it neutral. So this parallel neutralism between matter and deep space is a negative charge, weightlessness, uh, no time dilation as you accelerate, and the space, just the opposite of positive matter, negative energy or negative matter, which is dark matter or dark energy, does just the opposite. Now, this is not in relativity or any in the textbook. Relativity was a textbook. GRT, general relativity, is a textbook study taught in universities. It talks about positive matter, but it doesn't talk about negative matter. Uh, it illustrates gravity, but it doesn't. It tells how heavy things are, how moving objects on our planet increase in acceleration when they move or are accelerated, but it has nothing to do with travel in space. So his conclusion was space is the same, that uh, the energy in the center is still positive, but low density. So again, I say, well, how come the planets and galaxies don't fall? In this video in all my videos and books, I illustrate a perfect vacuum space field, a push force at the Hubble rate. Now, again, they said this pressure from pushed on negative energy or empty space or space itself is low density. But if the field is, the dark matter is low density, and the Hubble sphere, the balloon that's expanding our universe, is getting bigger, it's putting pressure on the space, on this low density. And instead of just a low density, it's rippled by the expansion, which is greater than the speed of light, as Hubble explains it. Though it's only 43 miles a second. Just think about what it's pushing on all the galaxies. So the sphere intensifies the negative pressure that is in dark matter or space itself. Think of it as create falling in the ocean and creating these big waves. It doesn't add a constant. In other words, it just creates waves by getting bigger. And it causes the universe to accelerate. Hope you like my videos. I just wanted to put this in. This is a new part of expanse space, which is the field that I'm researching. No one else is, so I am. My name is Rod Kowicki. Thank you.
In quantum
Fuck is it?
As the animated stars expand outward, the title glows. Introducing the Kowicki Spacefield Speedway, a futuristic concept that pushes the boundaries of superluminal travel in the vast cosmos. A striking visual of a light cone graphic showcases the no-go FTL zone, highlighting the challenges of faster-than-light travel. Delving into the realm of theoretical physics, the text explores the reasons behind the impossibility of FTL travel, citing Einstein's theory of relativity. In a bold proposition, the question is posed, could we harness the forces of cosmic expansion to achieve superluminal speeds in the future?
Albert Einstein did not delve into dual acceleration within his theories of relativity, as his main focus was on uniform acceleration and the equivalence of gravity, rather than the intricacies of relative accelerations between independently moving frames. Special relativity centers on inertial frames and assumes non-accelerating or uniformly moving observers, omitting accelerated motion from its fundamental principles. General relativity, on the other hand, incorporates acceleration but predominantly deals with local effects and acceleration within a single frame. The equivalence principle in general relativity posits that acceleration and gravity are indistinguishable, offering a more nuanced perspective on acceleration within a curved spacetime.
Modern cosmology has revealed a universe that is expanding at an accelerating rate, yet still maintains gravitational cohesion on various scales. The commonly accepted explanation for this phenomenon is the existence of dark energy or a cosmological constant. Our proposed framework, quantum vacuum field dynamics, offers an alternative perspective. According to this model, the vacuum of space is not inert but rather an active and negatively energized field. Mass energy entities interact with this field to create gravitational wells by bending spacetime inwards, while also inducing repulsive expansion in less dense regions. Unlike traditional theories, our approach incorporates a dynamic vacuum stress energy term that adjusts based on the distribution of matter.
The Kawecki theory can be better grasped by comparing it to a fish swimming in the ocean. The fish modulates the speed of its rear fin to achieve acceleration, akin to how a spacecraft navigates in the vacuum of space. As the fish attains its top speed, it eventually halts. This principle parallels the propulsion system of a spaceship, which employs engines to speed up and come to a standstill in outer space. Just as the fish experiences a pushing force in water, a comparable repelling force appears to exist in space, propelling entities at a steady pace, reminiscent of the Hubble expansion. This persistent thrusting force is responsible for propelling space, generating a consistent velocity like that of any moving entity.
The stars didn't twinkle out here. They stretched, lines of white fire slashing across the black canvas as the ship rode the invisible tide. Inside the cockpit, Commander Aylin watched the chronometer tick in perfect rhythm. Local time was preserved, her heartbeat steady, her breath slow, but outside? Outside, space itself moved. There were no engines firing, no ion trails. Just the soft hum of the repulsive drive, warping the field behind the ship, pushing against the very structure of vacuum. It was as if the vessel floated on a self-generated wave, its repulsive swell shoving the universe backwards, creating momentum by moving the medium instead of the mass.